Hello students, it's me Vivek sir, and today we are going to study the effect of change of temperature. Clear? See children, we can change the physical state of matter in two ways. First, by changing the temperature, and second, by changing the pressure. Clear? Children, sometimes we think that what are the things that is required to change the state of matter from solid to liquid and liquid to gas. So these are the temperature and pressure. Children, when we say that we can change the state of matter by changing the temperature, it means the state of matter can be changed by heating and by cooling. See, this is a form of ice. On heating, children, this heat energy breaks the force of attraction between the particles and make a space. When it makes a space, the ice, which is a form of solid, start expanding and convert into the water. And when water is cooled, the particles coming close to each other and attracting is there, children, and convert into the ice. Clear? Now second, by changing the pressure. When we say that we can change the state of matter by changing the pressure, it means the state of matter can be changed by increasing or by decreasing the pressure on it. Let us take an example to understand this topic. See children, look at this diagram. Children, we know it very well that gas is a form of matter which have a lot of space between the particles. Now we reduce the space between the particles by enclosing in the cylinder and compressing on it with the piston. If enough force is applied to the piston, the gas is highly compressible. Clear? And when it highly compressed, the particles of a gas coming close to each other and start attracting. When it comes close to each other and start attracting, the particles form a little space as compared to the gas and convert into the liquid. Clear children? Now see children, solid on heating it convert into the liquid state, that process known as melting, and when liquid state on further heating it convert into the gas state, that process known as boiling. See children, it means heating is very important to convert the solid into liquid and liquid into gas, children, because heat breaks the force of attraction between their particles either in solid state or in liquid state and convert into the other phase. So children, the heat energy which has to be supplied to change the state of matter from solid to liquid or liquid to gas, but without changing temperature, that is known as latent heat. Clear children? The heat energy which has to be supplied to change the state of a substance without changing temperature is called its latent heat. Clear children? Latent heat is of two types. First, latent heat of fusion and latent heat of vaporization. See, latent heat of fusion, it means conversion of solid to liquid, the heat energy that convert solid to liquid. The latent heat of fusion can be studied by performing an activity as follows children. We take some crushed ice in a beaker and suspend a thermometer in it. We note the temperature of the thermometer. There is a 0 degree Celsius. Clear, children? The temperature of ice is 0 degree Celsius. We now heat the ice gently by using burner, children. On heating, ice starts melting to form water. This is a water and this is ice. And we keep on recording the temperature of when ice melt into the water. As more heat is given, the more ice heat to form water. But the thermometer reading remains constant at 0 degree Celsius. Clear, children? Now this so that there is no rise in temperature during the melting of an ice. Clear, children? The heat which is going into the ice but not increasing the temperature and convert the ice into the water, that heat is known as latent heat of fusion. So the question is, where does the heat energy goes? Now the heat energy, this heat energy which is supplied to change the state of matter from solid to liquid, that is known as latent heat of fusion. Now the question is, where does the heat energy goes? See, all the heat energy is used up in changing the state of solid to liquid, and it by overcoming the force of attraction between the particles. Clear, children? Now we can write the definition. The quantity of heat required to convert 1 kilogram of solid to liquid without change in temperature, children. Without change in temperature. Because we have already recorded the temperature in thermometer, before and after the temperature remains constant. And now we will now discuss why the temperature of melting ice does not rise even the heat is continuously supplied. Clear, children? This can be explained. Children, ice is a solid substance, so the particles are closely packed. Clear? And the heat which we supplied to ice during melting is all used to overcome the force of attraction between the particles. Clear, children? So that they become somewhat loose and form liquid. Clear, children? This heat does not increase the kinetic energy of the particles, and hence no rise in temperature take place during the melting of ice. Clear, children? Now second, latent heat of vaporization, liquid to gas change, children. The latent heat of vaporization can be studied by performing an experiment which is as follows. Clear, children? We take a water in a beaker, clear, and suspend in a thermometer in it. We heat this water by using a burner and note its temperature. And we know it very well that water always boils only at the temperature of 100 degree Celsius. At the temperature of 100 degrees Celsius, water boils and starts changing into the steam, children, which is a gas. As more heat is given to water, more steam is formed. but the thermometer reading remains at 100 degree Celsius. So children, it's showing that there is no rise in temperature during the during the boiling of water. Clear children? Thus, once the water has begun to boil, the temperature remains constant at 100 degrees Celsius until all the water has changed into the steam. Clear children? Now, the heat which is going into the boiling water but not increasing the temperature is the energy required to change the state of water from liquid to steam or gas. This is known as latent heat of vaporization. Clear children? So we can write the definition. The quantity of heat required to convert 1 kilogram of the liquid to vapor or gas without change in temperature, that is known as latent heat of vaporization. Clear children? Now we will discuss why the temperature of boiling water does not rise even though heat is being given continuously. Clear? So this can be explained as follow. Water is a liquid state children. Water is a liquid state. So the particles of water attract one another. The particles of water attract one another. The heat which we supply during boiling is used. The heat which we supply, clear, is used to overcome the force of attraction between the water particles so that they become totally free and change into the gaseous state. This latent heat does not increase the kinetic energy of the water particles and hence no rise in temperature take place during the boiling point of water. Clear children? Now children, our next topic is the common unit of temperature and SI unit of temperature. Clear children? Generally children, we use Celsius scale of temperature for measuring temperature in our life. So the common unit of measuring temperature like melting point, boiling point is degree Celsius and denoted by this. On Celsius scale, the melting point of ice is 0 degree Celsius and boiling point of water on Celsius scale is 100 degree Celsius. Now children, there is another scale of temperature that is called Kelvin scale, and this is the SI unit of temperature. Clear children? Kelvin scale is the SI unit of temperature. Now the melting point of ice on Kelvin scale is 273 Kelvin and boiling point of water is 373 Kelvin. Now we are going to study what are the relation between Celsius and Kelvin. See children, relation between Kelvin scale and Celsius scale of temperature. Temperature on Kelvin scale is equal to temperature on Celsius scale plus 273. So we can write Kelvin is equal to degree Celsius plus 273. This is the relation of Kelvin scale and Celsius scale. Let us take an example to understand this. Convert the temperature of 225 degrees Celsius into Kelvin. We have to convert this Celsius into the Kelvin children. So we know that the relation between Kelvin and Celsius is equal to degree Celsius plus 273. Now put the value of degree Celsius 25 plus 273. Now we will get 298 Kelvin. Clear, children? Now see, children, second example. Convert the temperature of 300 Kelvin into the Celsius scale. So write the relation of Kelvin and Celsius, children. Clear? Now in this question we have to convert Kelvin into Celsius. Now put the value of Kelvin, children. 300 is equal to degree Celsius plus 200. Clear, children? 273. Now when 273 goes on this side, plus symbol convert into the minus. 300 minus 273 is equal to degree Celsius. Now degree Celsius is equal to, subtract 300 and 273, children, will get 27 degree. Clear, children?